Hello, my name is Sydney Graham, and I'm a master's student in the turfgrass breeding and genetics group. Today, I will be telling you about breeding for freezing tolerance in warm season turfgrasses. Because North Carolina winters can be so variable, pinpointing the cause of winter injuries in field studies is often difficult. Ideally, for a freeze event, we would like to see a period of cold above freezing temperatures prior to the freezing event. This is what we call acclimation, and it improves the freezing tolerance of turf grasses. Often in North Carolina, what we see instead are freeze-thaw cycles. These cycles deacclimate the plants by exposing them to warm temperatures after acclimation occurs. Then, when the freezing again occurs, more injury is sustained. Other causes of injury could include snow events or sustained cold temperatures. To combat this, for our freeze tests, we use growth chambers and freezers, which allow us to use specified temperatures, specified cooling rates, control the duration, and potential acclimation treatments. So here we have both zosyiagrasses and St. Augustine grass. On the far left, you see St. Augustine grass in a growth chamber. In the center, you see St. Augustine grass in a freezer. And then on the right, on the top, you see zosyiagrass in a growth chamber, and on the bottom, zosyiagrass in a freezer. You see these wires in the freezing chambers, which allow us to measure the temperatures within the freezers, so we know exactly what causes the response in our plants. Acclimation treatments and temperatures also allow us to get better separations across cultivar for freeze response. So you can see here we have 3 different cultivars at 4 different temperatures and under 2 different treatments. As expected, our non-acclimated plants survive less well than our acclimated plants, and Meyer generally has better freezing tolerance than Victoria. We see for all cultivars, they survive better at -8 than -11, as expected. And we see certain treatment and temperature combos provide different separation for the plants, such as this -10 for acclimated. We see Victoria does not survive very well, whereas Meyer does very well. Compare this perhaps to -8 for acclimated when all plants appear to survive well. We also have St. Augustine grass. So we see in this figure here, we have 4 different treatments, and this is measuring the recovery after freezing. So on the left, we see non-acclimated. So these plants were put in the freezer after being exposed to just warm temperatures, and they don't have that much survival. Then we have our cold acclimated plants, which show a lot more recovery after freezing. And then we have deacclimation. So these plants were exposed to the acclimation treatment, and then were exposed to warmer temperatures following the acclimation treatment. And these temperatures were either 13 or 21 degrees Celsius. So DCA is 13, and DCA 21 is 21. We see both of these treatments decrease the regrowth following freezing. Data collection methods and times allow us for better and more efficient estimation of cultivar freeze responses. So we see here St. Augustine grass with and without acclimation treatment, and it matters what time you evaluate your plants. See, if you evaluate them immediately following, you won't see much difference between them, but come 6 weeks, we see much difference between our not acclimated and our acclimated pots. We also can improve our rating method by going from a visual method where we are a little bit subjective to a digital one. So in a digital rating system, we would have some sort of setup as seen on the left here, where we have a camera at a certain height above the pot with specific lighting. And then we take pictures over time. So you see here we have 2 different pots at pre-freeze, 1 day post-freeze, 5 day post-freeze, and 12 day post-freeze. This top pot here, you see we have some survival, but we also see some damage, which we can quantify using the number of green pixels in the figure. And then on the bottom pot here, it looks like it's completely dead at day 5, but we see substantial regrowth by day 12. And again, we can quantify this using these images and extracting the number of green pixels in each. Genes associated with freezing can be identified when lines have different responses to the same conditions. So that's why it's very important that we are able to observe separation across lines. So here we have zosyiagrasses, and these were frozen, and you see different responses from different lines. So each line is in one of these little tiny pots here. And so some of course die and some survive, and we can use that to identify which genes are associated with this survival. We also can then pinpoint which genes are turned on and off due to cold and freezing using transcriptomics. So in this type of setup here, we have our freezing protocol. We have a cold temperature, and then we decrease to an even colder temperature before increasing. And we can take tissue samples at both time A and time B and say we have two different lines here. We have our green line and our blue line. And we can extract the RNA, and then we can sequence that. And that allows us to identify which genes are transcribed or turned on. So here for the green line, we see at time A, there's a few genes. At time B, there's a few genes. But most of the time, all the genes are turned on. So in both time A and time B, all those genes are turned on. Whereas for the bluegrass, we see at time A, there's a bunch of genes turned on, and then not too many shared genes across time A and time B. And then at time B, there's a bunch of genes turned on. So what we're really seeing here is our bluegrass is having a very strong response to this change in condition. So whereas our green grass doesn't really turn on genes based off of this temperature chain, our bluegrass is initiating this response. So then if our bluegrass survives better, we can say, okay, some of these genes that are turned off or on are associated with freezing, which is really important for us to know. Our ultimate goal, of course, is to improve the efficiency of breeding. And so we can do this by identifying genes with significant effect on freezing tolerance and using marker-assisted selection. So bringing some of this together, we have multiple different strategies that are kind of concurrent and that all complement one another. So we can take the genomics approach and combine it with the transcriptomics approach, and then identify some proteins that are impacting freezing tolerance. And then we can target that specifically using marker-assisted selection and improve the efficiency for breeding and freezing tolerance. Altogether, we are hoping to develop St. Augustine grass and zosyiagrass varieties with improved freezing tolerance. And thank you very much. Hope you enjoyed the video.